Okay, so for the next test, we've set a date of the 12th to the 19th. And we will not have exam 3. We're just going to do 2 tests and a final. I would like to continue doing quizzes and post quiz number 2 this Monday. And it will be due on the 12th. 5th to the 12th. And we're going to have, I want to make homework for sections 3.4 and 3.5, and that's what the test will go up to, 3.5. All right, we're doing notes for 3.7, and then we're going to jump to 3.11, and then we're done with chapter 3. So I want to pick up with a problem we did before. The bug problem. Continue. So I'll send an email out to everybody about the plan. We will do a review for the test, and of course we'll do a review for the final. So let's see, we said A, B, C, D, E. We did part F, so this is part G. Okay, we want to determine when the bug speeds up and slows down. Okay, so I'm going to write down what it means to be speeding up and to be slowing down. So first part. Speeding up means that the velocity and acceleration have the same sign. I'm just going to put equal same sign, but it means they both have the same sign. All right, it's slowing down if velocity and acceleration have opposite signs. And acceleration. Or opposite. Okay. I have the sign chart that we did before, and then we'll do a sign chart for acceleration and then compare the signs for both. Okay, so actually we'll work on the sign chart for acceleration first, and then I'll copy down that other chart we did last time. So first we want to set the acceleration function equal to 0 to see when, when or what intervals we want to test to have a positive sign or negative sign. That function is 16t minus 18. And I got t equal to 3. Oh, 6t. So add 18, divide by 6, you get 3. Okay, so we have values of t. Start here. And as time, we're starting at 0 and moving over towards positive values for t. And for 3, we have a of t equal to 0. I want to write down the function just on the side. So a of t is equal to 16t minus 18. So we're testing from 0 to 3, and then from 3 over to 8. We decided to stop at 8. Okay, let's put in something like 1, and we'll have 16 times 1 is 16, subtract 18, so that's a negative sign. Now over here, test a number like, I'm going to say 4. 4 times 16, subtract 18 will be positive. And then we copy down that chart we did last time and have it match up underneath. Still values of t. And we'll have this copied straight down to 0. But for the acceleration, for the velocity function, we have points at 1 and 5. Stop. I'm going to put a mark for 3, but it's not. It's mostly so they can match this graph to that graph. But really here, we're labeling 1, 5, and 8. We did the signs last time. From 0 to 1, it was positive. From 1 to 5, negative. And 5 to 8, positive. So first you're going to talk about speeding up. Speeds up from the intervals 1 to 3, where we have the same sign, the same signs. And also from 5 to 8, where they're both positive. Let's do this. Okay, 1 to 3. Not including either of those numbers. And then from 5 to 8. If we're slowing down, that's where those signs are opposite. So right here is a positive sign from 0 to 1. Up here is a negative sign from 0 to 1. So that's why we slow down. Also, let's see, that's the same. Right here is a negative sign, whereas up here is positive from 3 to 5. So we have it slowing down from 3 to 5. And one more example for this section about displacement and distance. Okay. We have just a graph, but I have another similar bug traveling in a straight line. And the values on the number line are for position. So this is in inches to -1 over to 5, 6, and 7. We're going to start at 5 inches. Let's see. Okay, and go over to 7. And then back to -1. And then over to 6 and stop. Okay, we're going to find displacement and then distance traveled. Let's try that. All right, we take the final position and subtract the starting position. That's your displacement. So we stop at 6 inches and then subtract 5 inches, so 1 inch. Okay, distance traveled. So we're going to add all of those distances you compute by adding the forwards and backwards motions together. Okay. So from 5 to 7 is a distance of 2. From 7 to -1 is a distance of 8. So add those together. And then the last one we're going to add is from -1 to 6. So a distance of 7. I think that's it. And it's in inches. Okay, I think we've still got time. Oh yeah. So we're going to start 3.11. Should be hyperbolic trig functions, but hyperbolic functions. Okay. Alrighty, so a bit of an intro, and then we're going to define each of them. We also kind of want to talk about how to pronounce all of them. And then we may save examples for later. So these hyperbolic functions are specific combinations of e to the x and e to the -x. Also, they have a connection to the hyperbola x squared minus y squared equal to 1. And that's in a similar way that the trig functions are connected to x squared plus y squared equal to 1. All right, the first one we're going to do is written sin h of x, sin parenthesis x. There are two ways, well, a few ways, I know two for sure, to say it. It's like a British way would be to say it shine. An American way, and the way I've written down, is to say it as cinch. Rhymes with pinch. Okay, so cinch of x is equal to e to the x subtract e to the -x divide by 2. The next one would be spelled COSH of X. This one we're going to say is like Kosh, similar to Posh. Let me make sure I got that. Cinch rhymes with pinch. Kosh rhymes with, well, Posh. And then hyperbolic, oh wait, okay, so it's hyperbolic sine, hyperbolic cosine, and this one's equal to e to the x, add e to the negative x, and divide by 2. All right, and then hyperbolic tangent, TANH of x. I wrote this one would be, check it out though. And there's a few ways to say it. We're going to say it tanch, rhymes with ranch. Tanch. Okay. And that one is the cinch of h divided by cosh of h. Cinch of x divided by cosh of x. Okay. And what you get is C. E to the x subtract e to the negative x is over e to the x plus e to the negative x. And just check it. We still have time. So I think we can do the next ones, which I didn't check out how to pronounce, but just kind of do my best. Oh, I could just say hyperbolic. Okay, so number 4 would be hyperbolic cosecant of x. And so it's cosecant hyperbolic function, and we have it as 2 divided by e to the x. Oh, that makes sense. Subtract e to the negative x. It's going to be 1 over that. No, this sine would be secant, so 1 over cosh of x. think I just got that wrong. I can check it here. It would be 1 over sine is cosecant. So similar for hyperbolic cosecant, 1 over hyperbolic sine. Okay, number 5. Secant, hyperbolic secant of x. So it would be a 1 over cosh of x. So 1 over that would be 2 over e to the x, add e to the negative x. Okay, almost done. Last one, number 6, hyperbolic cotangent. So you can flip hyperbolic tangent over and have e to the x, add e to the negative x. Is over e to the x, subtract e to the negative x. Cool. Okay. We do have more time. Let's see. So my notes have the graphs of some of these functions and some more explanation. And I have some hyperbolic identities. And let's skip to this part. So I'm going to put down 3 identities and we're going to talk about derivatives. And I think that'll be it for today. Okay, so first, identities. We have cosine h of x, cosh of x squared, cosh squared of x, subtract sinh squared of x. And that will equal 1. Next. 1 subtract tan h squared of x. Tan h squared of x equals hyperbolic secant squared of x. One more. We're going to have hyperbolic cotangent squared of x. Subtract 1. And that's equal to hyperbolic cosecant squared of x. Okay. And now derivatives, and then we'll call it good for here for now. Hyperbolic functions. Let's do the derivative with respect to x of sinh of x. Equals cosh of x. Cosh of x. The derivative of cosh of x is equal to sinh of x. Sign this one. Let's do tangent. Tangent of x. And we get, let's check it out. Hyperbolic secant squared of x. So SECH squared. 3 more. The next derivative is hyperbolic cosecant. This one is negative is a hyperbolic cosecant times hyperbolic cotangent. Cool. All right, and oh, we have more. Okay. The derivative of hyperbolic secant squared of x. Okay. This is equal to negative hyperbolic secant SECH of x multiplied with tangent of x. And we're at the last one, the derivative of hyperbolic cotangent. So cotangent, then add an h, coth of x. And that one is negative hyperbolic cosecant squared of x. And then I doubt that we're going to do proofs. I'd rather do examples. We'll do examples next time. So we'll continue 3.11 next week.